Hello there, my name is Thomas. I'm representing investmentexcel.com, a platform where you can download supporting material for your education or perhaps your business within advanced or slightly advanced topics in finance and economics. Today's session is about the risk measure value at risk, VaR, and how it can be calculated with the use of matrix notation. Particularly, we will look at estimation of VaR for a 5-asset US portfolio. This topic is slightly advanced, and if you are not familiar with matrix notation or standard deviation, I would suggest that you look at some other sessions we have on investmentexcel.com that are more in the standard area, more basic. This video and the Excel workbook, including codes, can be downloaded, of course, on investmentexcel.com, but also on spotify.com. Let's dig into it and just look at 5 assets, 5 stocks from the US market: Microsoft, Google, Netflix, Apple, and Amazon. For sake of simplicity, we assume only 5 observations with return series on all 5 stocks. And now, before we can calculate VaR, we need to calculate the covariance matrix, and before we can calculate the covariance matrix, we need to calculate the correlation matrix and also what we call the standard deviation matrix. So let's look at the correlation matrix first, which is a symmetrical table of correlation coefficients between the 5 stocks. And always when you build a correlation matrix, you can check if you have done it right by at least noting that you have ones on the diagonal, because all assets correlation with themselves is 1, and the off diagonals correlation between Microsoft and Google, for instance, minus 0.51, and so on. And being a symmetrical matrix means that the values north of the diagonal are exactly the same south. So the correlation between Microsoft and Google is by construction the same as the correlation between Google and Microsoft down here. So this is the correlation matrix, and in Excel there is the hard way to build it, which is what I have done here, manually just taking the correlation starting with Microsoft, which we have to fix because I want to calculate the correlation between Microsoft and all the others, and perhaps I should remember to put in the function. So I'll try again. Microsoft, and it starts off with itself, and then I can copy paste, and in this way you can do it all the way down. You just always have to fix the series. In this case, for instance, Google, fix the Google series here, and Netflix, and so on. And I'll just remove this color because I don't like a miscoloring here. So this is the correlation matrix built in the tough way. The easy way is to use the Excel's data analysis function in the data category, and if you go up into your data category and you cannot see it, you need to go to File, Options, Add in, and then somewhere here you will find it, and you have to add it. Type Go and then OK, because the add-in of the analysis toolpack here is not by default a part of the functions. But now I do have it, so I go to analysis and I go to correlation, and I can actually just type in the table of the original data set, and it assumes it is built on a column basis. And if I type here, it will open a new worksheet. I'll just call it test column. I'll just test my own manual numbers and see if they are correct, and they are here. You could have added the names as well in the menu. I didn't do it. So here is actually the same numbers as up here. I would need to transform it to make it look better. So here we go, and we see clearly the structure here and here, so minus 0.51, 2, and so on. And Excel doesn't include the other side of the diagonal because it's assumed that they are the same. So this was one way of doing it also. Okay, let's move on. Now we have the correlation matrix. We need a standard deviation matrix. It's a part of the calculation of the covariance matrix that we ultimately need before we can calculate VaR. And the standard deviation matrix is simply a zero matrix, 0 in every cell, but on the diagonal you need to type in the standard deviation of every asset. So this is the standard deviation for each company on the diagonal, and then you have zeros on all of diagonal elements. Having correlation matrix and the standard matrix, we can go to the covariance matrix, which is a summary of all variances of the stocks on the diagonal. That's the variance part in the label here, and then you have the covariance being all of diagonal elements. And again, we have a symmetrical structure also in the covariance matrix, so the covariance elements are the same on both sides. And if I calculate the covariance matrix with Excel, I would also get I'll get blanks here, and I'll just show you that Excel is actually capable of doing it. You see the covariance matrix, the covariance function here. I will not do it this time. So the covariance matrix is really a covariance variance matrix, but we normally just call it a covariance matrix because it's a horribly long word, covariance variance matrix. So we say covariance matrix, and it includes the variance elements on the diagonal. And perhaps I should just add here that one intuition by just calling it a covariance matrix is that you can actually consider it just as covariances only. But on the diagonal, you just have the covariance with the stock itself, which then gives the variance. The covariance of a stock with itself is the variance. So this is why perhaps you can argue that you could call it a covariance matrix, and you don't need the variance expression as well. All right, now this covariance variance matrix constitutes the multivariate distribution of the sample. So all variances, all covariances, that is the dependent structure between the stocks. Obviously, if they were uncorrelated, all the stocks, then we would have zeros on all off diagonals. Now I would like to calculate an actual portfolio risk measure of variance. And for that purpose, I need the covariance structure for the 5 assets in the portfolio, and I also need the weights of the portfolios. So the risk is not independent of the weight, nor is it independent of the correlation. So the way I calculate this is to take the range of weights and multiply it by the covariance matrix, and then I multiply it again just with the transposed. And the reason I transpose it is to make sure that the rank is correct. The dimension is correct in the way we multiplied the matrices and the vectors. And this gives this variance, and as always we can calculate the standard deviation by just square rooting the variance. So now we have a standard deviation measure of our portfolio with 5 assets given the weights, and we can now calculate the value at risk as a shortfall risk measure. And in this case I would like to calculate value at risk 95, just VaR 95, which is the most used risk measure in practice and also in legislation. And it's a one-side test. It's a left tail test of figure. So I use the Z score, which is aligned to the 5% one side of the normal distribution. This means that the VaR 95 is minus 60% or 60 basis points on a daily basis. And this means, in terms of interpretation, that there is a 5% chance of losing more than 60 basis points a day in this portfolio. We could annualize this by annualizing the standard deviation up here using the square root rule, I would then multiply it by square with 252, assuming 252 trading days a year. So an annualized risk measure for this portfolio would be this. So on an annualized basis, the value at risk is -9. So there's a 5% chance on a yearly basis that this portfolio will lose 9%, 9.5% or more. So it's the VaR, remember, is a cutoff measure. So the 5% includes all left side outcomes to the left of the minus 1.64 set score. So it only says that the chance is 5% of losing 9%, 9.5% or more. So it could include also 50% loss. So now we have generated the VaR, and I just need to say that this is a parametric measurement because we have used the normal distribution. We could have used also the empirical measure, to the empirical VaR, which uses a historical time series and builds a distribution from history and not from a parameterization of the normal distribution. I should also say that if you would like to have this in monetary terms instead of the percentage terms, we would just multiply it by the market value of the portfolio today, and that's it. Thank you very much.